So now we're going to make another comparator circuit. This one also is a light dependent version right there. It's going to respond to light, but we made the non-inverting comparator circuit with the light dependent resistor. Now we're going to make the inverting. So what that means is if we get enough light, a high input, that'll be a low output. If it's dark enough that we get below half the supply voltage right there, because we got a better connection right there, it'll be a high output, as close to the positive 5 as it can get. It doesn't get to the rails with the load on either end right there, and it never gets to the rail on the positive side because it's a single supply op amp, single supply integrated circuit. So I need to put the divot to the left right there, and then you can see LM358, and then you can see P at the end there, and I don't know why this isn't looking very good. Yeah, let's get this closer. So yeah, there you can see the part number. So that P means it's in the plastic package right there. So I was guessing earlier in previous videos that maybe it's an improved version of the LM358, the original, but somebody pointed out all you gotta do is look at the data sheet and see that it stands for the plastic dual inline package. And I verified that by looking at the data sheet, and they were right. So they commented on an earlier video. Now, these jumpers are just to transfer the power from one side over to the other right there, because they're not normally connected. We have the component in the board right there. I have the pin layout right there. I also have the kit that I got the LM358 out of. It has the pin layout on it, so it's good to get these kits. I would go with the bigger kit, but I already had a lot more integrated circuits and stuff when I bought that, so I bought the smaller one. Save a little bit of money too. So in any case, we come back to the circuit. So I put the numbers on there as well. Let's do the output first. So we're going to take the blue LED. I like to use it to indicate the output is low. So that means if we come from the positive supply right there, then we get a resistor going to the output. It will light up when the output's connected to ground, and as good as it can. Right there, you can see that path, although I swapped the position of the LED and resistor. So long lead the anode to the positive side, short lead the cathode to the negative side. If you put the resistor in backwards, it will not light up. So it will not light up at all, because the only time you'll get a low output there is when it's connected to ground. And so if it's high, the LED will be off, even if it's in the right way right there. So you put it backwards, there's no way for it to light up. Now we're going to take the red LED, and I'm going to put the LED to the supply rail. It goes to ground, so that's the shorter lead to ground. Longer lead, the anode, I have up one spot. Shorter lead is the cathode. And this should be a 220 ohm resistor, and I had the light over there for looking at the part number. Kind of need to shift the light. But in case, we're going to put it up there. I didn't mean to bend that the way it did, but it went in pretty easy, so not too bad there. That's going to the longer lead up on top. Again, you got to put it in the right way or it won't light up, and then it's headed to the output. Now, we have a couple of fixed value resistors of equal value, 10,000 ohm resistors, going to the non-inverting input. That is lower on the physical component than the inverting input. So always be careful looking at schematics that you don't follow what's higher and lower on the schematic. You got to make sure you pay attention to what it is on the physical component. So we're going to set this to the inverting input, and it's kind of nice to just put the light dependent resistor to the positive supply right there, and then we're going to adjust the sensitivity with this 3,000 ohm resistor. And sometimes you can go like to the negative supply right there for the op amp. This jumper makes this row right there the exact same connection as the negative supply. So it doesn't matter which one you plug it into, whatever looks the best, especially when you're prototyping on the breadboard. Now, our fixed value. So this is going to set half of the supply voltage, 2.5 volts when we power it with 5 volts, at the non-inverting input right there. So usually I like to do the positive above the negative, and then usually I leave some space in the middle for the negative side of the voltage divider to go. And I think both of these, okay, the top one, the color code is backwards, if you try to read it. And the bottom one, it's well, it's going up more than I expected, so it was open enough where kind of naturally went there, so I plugged it there. But yeah, that's really about it. Fixed voltage to the non-inverting input. Inverting input has our changing voltage, so when this gets a higher voltage, the inverting input, than the non-inverting output goes low. You get a lower voltage at the inverting than the non-inverting, output goes high. Output is the opposite of the signal direction of our inverted input. So up to now, we didn't have the power supply connected. We still don't. We have to do that. So I got these header pins that I can clip to right there. And I'm not going to worry too much about covering this up. Also, the output is off, which you definitely should do if you wire it up while the power supply is connected. And if you got batteries or something, then you definitely want to disconnect the battery until you're done wiring it up. But here we can actually turn this off, so we could wire it up with it connected. Also, I got lower resistance, 220 for the red LED, because they're not as bright as the blue LED right there. And actually, we don't have too terrible a different amount of voltage across these two resistors. So you definitely want a much lower value resistor across the red LED. We looked at that in other videos. But that's it. Turn the power on. We got enough light falling on the light dependent resistor that the output went low. I cover it and the red LED lights up. It should be the dimmest lamp setting there. Okay. Okay, yeah, we got kind of a iffy middle right there. It could either be, okay, looks like a couple lowest settings. Also, it depends on where the lamp is. It's not in the same exact spot as when I made the previous video. So previous video, I had to get the lamp to the dimmest setting before it changed. That's what I had to do then. I was kind of expecting that now, but that makes sense. The lamp's in a different spot. But yeah, there you can see about 5 milliamps of current going through the red LED, and about 2 milliamps of current going through the blue LED. And blue LED probably a little bit brighter, but you can't tell because I had to get the lamp brighter to really show it. So, as I mentioned before, use a much lower value resistor for the red LED. But yeah, there you can see. Now, if we get it bright enough, that goes to the positive supply, so you know you get a high input, more than half of the supply voltage. Right there, it's closer to the positive supply, right there when it's brighter, and a low output. Output's going to ground. And then we get it dimmer. Again, we have the other side of the red LED to the negative supply, so you know the output is high, but it's darker now. So we got a lower resistance, or a higher resistance, I mean. It's not conducting as well, so we get a lower input to the inverting input right there. So low input, high output, high input, low output. Pretty straightforward. All kinds of ways to wire this up. It all depends on what you're already working with and what your goal is and whatnot. That is the main takeaway. There's no single correct way to wire up op amps. There's all kinds of options, unlimited options. So that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen and check out the links down below. They all help out a lot. I'll see you in the next video.